HarperCollins presents Einstein's Fridge, The Science of Fire, Ice and the Universe, by Paul Sen, read by Malk Williams. Prologue. Thermodynamics is a dreadful name for what is arguably the most useful and universal scientific theory ever conceived. The word suggests a narrow discipline concerned only with the behaviour of heat. Here indeed lie the subject's origins, but it's grown far beyond that, and is now more broadly a means of making sense of our universe. At its heart are three concepts: energy, entropy, and temperature. Without an understanding of these and the laws they obey, all science, physics, chemistry, and biology would be incoherent. The laws of thermodynamics govern everything from the behaviour of atoms to that of living cells, from the engines that power our world to the black hole at the centre of our galaxy. Thermodynamics explains why we must eat and breathe, how the lights come on, and how the universe will end. Thermodynamics is the field of knowledge on which the modern world is based. In the years since its discovery, we have seen the greatest improvement in the human condition in the history of our species. We live longer, healthier lives than before. Most children born today are likely to reach adulthood. Though much remains wrong with our time, few of us would swap places with our ancestors. Thermodynamics alone didn't cause this, but it was essential for it to happen. From sewage pumps to jet engines, from a reliable electricity supply to the biochemistry of life-saving drugs, all the technology that we take for granted needs an understanding of energy, temperature, and entropy. Yet, despite its importance, thermodynamics is the Cinderella of the sciences. The subject is introduced piecemeal in secondary school physics, and the concept of entropy, so vital to our understanding of the universe, is barely mentioned. I first encountered the study of thermodynamics in the second year towards my undergraduate engineering degree at Cambridge University, where it was presented as relevant only to car engines, steam turbines, and refrigerators. If instead I had been told that it provided a unified and coherent way of understanding all science, I might have paid more attention. Most adults are similarly introduced to the topic. Even ones who consider themselves educated are ignorant of humanity's greatest intellectual achievement in the sciences. We count calories, pay energy bills, worry about the temperature of the planet, without appreciating the principles underpinning those actions. The Cinderella status of thermodynamics is reflected in the way Einstein's science is remembered. All acknowledge his immense and revolutionary contributions, yet few realize the extent to which his work derived from thermodynamics, or that he made seminal contributions to the subject. In his so-called miracle year of 1905, he published 4 papers that transformed physics, including the one featuring the equation E equals mc squared. This work did not appear from nowhere, for in the previous 3 years, Einstein had published 3 papers on thermodynamics, and the first 2 of the Miracle Year papers, one on the atomic structure of matter and the other on the quantum nature of light, were continuations of that work. The third Miracle Year paper on special relativity took an approach to physics inspired by thermodynamics, and the fourth, in which he derived E equals mc squared, united the Newtonian concept of mass with the thermodynamic concept of energy. Of thermodynamics, Einstein said, "It is the only physical theory of universal content which I am convinced will never be overthrown." Nor was Einstein's interest in thermodynamics limited to its role in fundamental and theoretical physics. He cared about its practical applications, too. In the late 1920s, he worked on designing cheaper and safer refrigerators than those available at the time. This little-known episode was not a quirky sideline, for he worked for several years on the project and successfully raised funding for it from the
Sample complete. Ready to continue?